Hello, dear students. In this video, we are going to see about ambiguity in the grammar. So, in the previous video, we saw the second phase of compiler, that is syntactic analysis, also called as parsing. And we saw what this parser will do. So, the main purpose of parser or syntactic analysis is to check whether there is a syntactic error in the sequence of tokens. So that we saw. So to check this, it will have a context-free grammar which says the rules of the programming language. So now we are going to discuss about ambiguity in this grammar. So grammar says the rules. So when a grammar is there to say the rule to find out the syntax, this grammar should not be ambiguous. What is the meaning of ambiguous means? So here you can see if it is producing more than one parse tree, syntax tree for a given sentence or for a given string, then we can say it is a ambiguous. For example, here in this example, you can see if I want to generate a string called ID plus ID into ID. So it has two parts trees to generate the same output string. So it is ambiguous. So when we have this kind of ambiguous grammar, then it is very difficult to parse this kind of to use this grammar when we apply some parsing algorithm. So we have to eliminate this ambiguity from the grammar. So how to eliminate it? For example, if you have if your grammar have less associative operators, then what you have to do is, for example, what are the left associative operators? For example, plus, minus, multiplication, division. So when you, these are all left associative operators. So when you have this kind of operators, then in your grammar, then you can induce a left recursion. Or if you have right associative operators like exponential, in that case, you can induce the right recursion. So let us discuss this with an example so that you will be clear in this concept. Let me consider one grammar here. Let us take a grammar. E tends to E plus E. Another one is E can also be E into E. This is another production. And we have one more production. So these are the three productions we have in this grammar. So from this grammar, I can derive one of the output string as ID plus ID plus ID. So I'm going to repress. So I have to bring the string from this context-free grammar. So I'm going to represent the derivation of this input string through a parse tree. Let us start. One way to derive is I'm going to do the top-down parsing. So I'm going to start from the root node, and I'm going to take the next production as E plus E. I have taken this first production. And then this E I'm going to further derive as E plus E. And then this E can be further derived into ID, and this can be ID. So all these things is derived from this grammar. So E can be written as E plus E, and this E again can be written as E plus E likewise, right? Okay, so this is one way of bringing out the output. Okay, so if you see here, this is our output, ID plus ID, and here you have plus and ID. So finally, you got the output string. So same thing, you can also do it through another parse tree. So here, I'm going to use another parse tree to derive the same output string. Look at this. Again, I'm saying E plus E. I'm going to, because all operators here are plus only. So then now this time I'm going to derive this E to ID. And this E I'm going to further derive to E plus E. And then I'm going to derive this as ID and then this as ID. So which is derived using this context-free grammar. So now if you look at this, again I got the same output string ID plus ID plus ID. So finally we got the output. But if you see here now, for the same output string ID plus ID plus ID, I have two parse trees. See, if you see, this is one parse tree and this is another parse tree. So that is why this grammar is called as ambiguous. To bring the same output string, this is what the output string I want to bring. For the same output string, I have two parse trees. So it's an ambiguous grammar. So now I have to find which is the correct parse tree to be followed when I have two. So if you take this expression, or output string ID plus ID plus ID, first ID, both of the thing you have IDs, right? But if you take this, consider this ID. This ID is associated with, for this ID, this as ID is associated with, this plus operator is associated with this ID, the left side. It is not associated with the right side. When you do this operation, this ID will be added with the left side ID, right? So you look at the parse tree here. Which one is correct? So if you say here, this ID is here only, this ID. You let us give some numbers for you to understand this. Let me number this IDs. This is number 1 ID, number 2 ID, and number 3 ID. Okay. So now you see here, number 1 ID and number 2 ID is added. Then only it is added with third ID here. But if you see here, number 2 ID and number 3 ID is first added. That result is now added with this first ID, right? So here that is changing. So who will be the correct parse tree here is this one, not this one. Hope you understood, because here this ID is associated with this plus, not with this plus. That's why when you look at this parse tree, you have the same thing in this parse tree only. Because first two IDs are first added here, then only it is added with third ID. But if you look at this parse tree, first, second, and third parse tree IDs are added. That result is now added with the first. So this is not correct. So this is the correct way. So how can I, so now you can understand the association of this ID is done with the left one. So how will I rewrite this production? So this is what our original production is. E tends to E plus I, E plus E. So now I can rewrite this production to E tends to E plus ID. ID. Got it? So I'm going to induce the left recursion and I'm going to stop the right recursion. And same thing, I have written this E tends to E plus, instead of inducing the right recursion, I have replaced this E with ID so that I can eliminate it. I can fit it into the correct parse tree. Hope you got it. Let us, to make you a little more understand, let me take another one scenario. From the same grammar, what is the grammar? E tends to E plus E, E tends to E into E or ID. Okay, this is our context-free grammar. From this context-free grammar, I want to generate a output string now like this: ID plus ID into ID. So earlier example, we have all as plus operator. Now we have two operators. All are left associative, but you know the operator precedence. Multiplication have higher operator precedence than the plus. So to do this derivation, again, I'm going to do the top-down processing. So we already know this grammar is an ambiguous grammar. So because to bring one particular output, it is giving us more than one parse tree. So let us start it. One option for me is I'm going to start with E. And I'm going to take the first production E plus E. And further, this E is derived into ID. And this is now ID. This was, I'm going to take the second production. So E into E. And now this ID is derived into, this E is derived into ID and this E is derived into ID. So now again, we got it, right? We got the output, right? ID plus ID into ID. So we got the desired output string. Same thing I'm going to achieve with another parse tree as well. So here when I start, I'm going to start with the start symbol E. It's a top-down parsing. So it starts from the root. Instead of this time, I'm going to take this second production first. And now this E is derived into ID, and now I'm going to do like so okay. I'm going to do like this. I'm going to derive this E into E plus E, and this E I'm going to define as ID, and this E I'm going to derive as ID, and now ID. Now if you check again, if you see here, so again I got the same output, ID plus ID into ID. But if you look at closely to the both parts tree, both are different parts tree. So this is one kind of parts tree, this is another kind of parts tree. That is why we call it as ambiguous, right? Because I have more than one parts tree to derive the same output. Now we have to find which one is correct. So now from this we can understand, since plus have lower precedence when compared to star, so which operation should be done first? Multiplication. So look at this, both the parts tree. In this parts tree, which one is doing the multiplication first? So if you look at the first parts tree, addition is not done first, because if I get this result, then only I can add it with this ID, because ID plus, and it want to evaluate this, then only it can add it with this. Okay, so here multiplication is done first. But you look at this parts tree, who is happening first? See, if I cannot first do the multiplication because I know the one operand of this multiplication. If I want to know the second operand of this multiplication, first you have to do the addition. So if you look at this parts tree, addition is happening first, then only multiplication is happening. But you look at this parts tree, first multiplication is happening and then only addition is happening. So which one is correct? This parts tree is accepted and this parts tree is not accepted when you see the operator precedence. So, so likewise, you can eliminate this ambiguity. By giving the higher priority of precedence to the higher priority operator. So I hope you got it. What is ambiguity means, and how to check an ambiguity and how to eliminate it. Uh, Thank you, Ma. God bless you.